Welcome to the next part of the statistics tutorial, and in this part I explain to you how to calculate an effect size for a Wilcoxon signed rank test. So we had 5 different taping and bracing techniques, and we now want to know which one you should recommend to your client. And to do that we need to know how big the effect is that each of those techniques had. So we're going to switch between the SPSS output window, which is open at the moment, and a spreadsheet, Microsoft Excel spreadsheet that I've already prepared to save some time. Okay, so I'm going to open the Excel spreadsheet now, and I've already labeled this. So we want to calculate an effect size for a Wilcoxon signed rank test. The effect size is called R, and the calculation is based on dividing Z, which is the standard score, so units of a standard deviation, which is the distance to the mean of the normal distribution, and that's reported in the output in SPSS by the square root of n, and n is the total sample size, so basically the total number of participants that were involved in the test that you conducted. Okay, so the effect size convention, so how do you know if it's a small, medium or large effect? You know this because a person called Jacob Cohen published an article, and this is widely used as a convention to classify effect sizes. This appeared in the Psychological Bulletin, volume 112, issue 1, pages 155 to 159, and the university subscribes to this, so you can find that if you go to the library, and it's available online too. So actually I've got it here. And then you want to look at page 157, table 1, second entry, significance of product moment R, and the convention is that small, the lower boundary is 0.1, for medium the lower boundary is 0.3, and for large the lower boundary is 0.5, and we're using that. You need to read this article and understand it at least a little bit, otherwise you can't cite it in your references. Okay, so as I said, we need to transfer some of the output from SPSS into Excel to do the calculation. So make sure that the comparisons are in the same order as they appear in the SPS output down here. And then you need to copy the Z values. So double click on the output table, drag across the Z values, single right click and copy, go to the Excel spreadsheet that you should have prepared previously, single right click, and then paste special and paste only the text to avoid problems with formatting. N is the total number of participants for which the test was conducted. You can find this if you go to the active data set. Click on active data set. N is reported here, and for us in all cases it was 27, so I'm just going to enter this here, 27, and then copy it using the fill handle across. Okay, and now we want to calculate R. So let's look back at how we calculate R. Okay, so R is calculated by dividing the Z value by the square root of n. So enter an equal sign into the appropriate cell, click on where the Z value for that comparison is, and then use the / for division. Then type SQRT, so this is an inbuilt function in Excel, and that will take the square root of the number that's followed in the round brackets. So SQRT gives you that little tooltip, and it tells you returns the square root of a number. The number needs to be enclosed in round brackets, so open a round bracket, click on n, which is the number we want to take the square root of, close the bracket and hit return or enter on your keyboard, and that will calculate it. So as I said, the sign for R is irrelevant. So R can range from -infinity to +infinity, but we are only interested in the absolute value. So we're going to adjust the formula that we entered into the cell to display only the absolute values. Basically, we drop the sign. So how you do this is you type ABS, which is another inbuilt function, and the tooltip tells you that this returns the absolute value of a number or a number without its sign. So ABS, and then you enclose the whole formula you typed previously in brackets, press end on your keyboard to move to the end of this formula, close the round bracket, and then press return or enter on your keyboard. Now we have the same value but without the minus sign. And then you copy this formula across all of your comparisons, and that gives you the effect size. So you might also want to look at, was this comparison actually significant? So go back to the test statistics table, double click on the row that says asymptotic significance, drag across the p-values, single right click, copy, go back to Excel, single right click on the first cell, paste special, select text and say OK. And then you can either use a formula here. I'm just going to type it to not confuse things unnecessarily. So if this value is smaller than or equal to 0.05, the result is statistically significant. So here the difference is significant, so that's a yes. Here the result is not quite significant but close, so I call this marginal, and we set the cutoff point for this is 0.07. Here the result is smaller, so it's yes. Again, smaller, yes. And here it's larger than 0.05, so no, not significant. And then the effect size, so if it's at least 0.1 and smaller than 0.3, it's small. If it is at least 0.3 but smaller than 0.5, it's medium. And if it's at least 0.5 up to infinity, it's large. So here the first one is 0.47. So that's a medium effect size because it's smaller than 0.5. So this one is medium. The next one is also medium. Next one is still medium, although it's very close to large. Next one is large, actually. And the last one doesn't make any sense to say what the effect size is because the difference wasn't significant. So you shouldn't talk about the size of the effect if the difference wasn't significant. Okay, and now if you want to find out which taping or bracing technique you would like to use for a specific client, you basically pick the one with the largest effect size. So for us that would be the A60. If for some reason you're unable to do that technique, just pick the next highest. So you would then pick basket weave. After that you pick heel lock, and then the next one is figure of 8, and the air sports brace is not relevant because it didn't actually show any significant improvement. So last bit we have to do is we need to report the results of our tests, and to do that we need to copy some descriptive statistics across. You don't actually need to copy it, but it just helps for writing it up to have it all in the spreadsheet. So I'm going to do this. So I'm going to click in the SPS output on descriptive statistics. I'm going to copy the percentiles, so the 25th, 50th and the 75th percentile, by dragging across, single right click copy, move to the Excel spreadsheet, click in the first empty cell, single right click, paste special, select text and say OK. And now you've copied this, and then to report the results I'm going to just maximize the window. Okay, so reporting this. So I give you only one example, and that example is a comparison between no taping or bracing and the air sports brace, which was not significant. And this is how you write it up. So you would say the Wilcoxon signed rank test showed no significant difference in balance, or actually you might want to say postural sway. So use the correct terminology for your field. Between the unbraced condition, and then you report the median value. The median is the same as the 50th percentile. That's the value below which 50% of the observed postural sway measurements fall. And then you also report the semi-interquartile range. The semi-interquartile range is the range between the 25th percentile and the 75th percentile. And for us this is in the wrong order actually. So you should start with the lower one. So I'm just going to switch this. So the first value you report should be the lower one, and the higher one is the 75th percentile. So 9107 comes from here. It's the 25th percentile, and 17944 is the 75th percentile. And then you report the thing it was compared to, so that was the air sports brace condition, and again reports the median. So median is here, is the 50th percentile, the semi-interquartile range, lower value first is the 25th percentile, higher value next is the 75th percentile. And then to summarize the test, you basically report the Z value, which was, if we have a look at this, minus 0.576, and you round this to 3 decimal places. So here we round up, so it's minus 0.577. Report the p-value to 3 decimal places and the effect size to 2. And you should italicize any statistics, any letters that refer to statistics. And this is how you would report the test.